Okay, now today we look into chapter 5. Oh. Let me on the on already. Okay, so while waiting for the projector to lights up. Okay, we have 8 chapter. We have 8 chapter. We already cleared 4 chapter. We already do chemistry bonding, device structure, all these things that you see in your test 1. We already clear gases. We clear forces, liquid, solid, intermolecular forces. We clear solution. Today we look at acid and base, mean acid and alkali. Okay. Material for your lab already uploaded in ICE for your info. So you can download the lab sheet, and some question you can start to prepare already in the lab. Okay. So nowadays we have a lot of AI platform. Make full use of the AI. In my class, I encourage you to use AI, but don't over dependent on the AI. Don't copy 100% from the AI. You need to think a little bit. Okay, means in your report, don't copy 100%. For example, some phrases that are used by the AI, you also copy inside, means cannot lah. Okay. 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 Right. A bit small, but able to see. Able to see the last one. So again, just to rephrase, you have gone through test 1. Basically, what we test you throughout the semester is we will ask you to describe something. Okay. Like for example, test 1 question, last question, I ask you something about concept. So I ask you concept, definition, and you see the way I give you marks is based on definition laws. For example, ideal gas, you're able to write PV equal to nRT, I give you marks already. Things like that. Concept. Second one, you need to substitute the correct number, means you need to able to do analytical thinking. You're able to calculate something, right? So display some techniques in this one in lab lah. CO3, you have 3 labs. You have 3 labs in this semester. Okay. So we have done the test 10%. Your test 2 will be in week 12 or week 13, depend on our progress. Assignment I already give you on island. So most of you I expect will get full mark or nearly 80%. Okay. Tutorial question, assignment question answer, please include full unit in your calculation. Full unit and calculate up to maybe 2 or 3 decimal place. Lab report 15%. This one I will guide you through how to do it when we have time. Okay. So we will have lab maybe around week 12 or week 12 or week 10, something like that. Okay, final exam 50%. You need 80% for your attendance throughout this semester, meaning you miss 4 classes, you will be barred from final exam. Okay, right. Okay, so chapter 5, we will look at acid and alkali, or in other words, alkali mean base. Another word for alkali is base. So we will look at what is acid, what is base. Reaction, how reaction acid and base form. What is pH value? What is pOH value? Buffer solution. This one is a reaction of some solution. They already acid. You add more alkali, it will become acid. Means it will stay acid. Buffer effect means whenever, whichever how you do it, you try to neutralize it, it still stay at its form. Alkali stay at alkali, acid will still stay at alkali. Means there's a resistance of changes. Okay. If I need to summarize chapter 5, we only look at hydrogen and OH. Just to summarize chapter 5. We focus on H hydrogen and OH hydroxide. Okay, just a general, if you learn in, I'm not sure chemical one have or not. If your H plus is very high, H plus very high means a lot of mole of H plus mean it is towards acid. More H, acid. Less H or more OH, it become alkali. Okay, these two are balanced. And then the product, you take acid plus alkali, you'll get water. Because why? Acid, we focus on H positive. Alkali, we focus on OH negative. H positive plus OH negative, you get water. And then some products. But in chapter 5, when you answer chapter 5 question, you will see H2O in your reaction. This is the basic idea of chapter 5. So first session, we'll go through what is acid. We'll look at how to calculate H positive. Then we'll look at alkali, how to calculate OH. And then we mix this H positive plus OH negative. Then we do calculation. This is an overview of chapter 5. Now, okay, sorry, I should bring this gummy bears to the class. So I think most of us, we have a gummy bear before. So this one, I think most of the girls, they like all this sour flavor kind of sweet lah. So this one, if you buy a gummy bears, it will taste sour. So relate this test with acid or alkali. So if you taste something sour, like lime, it means you have acid inside there. This is a physical introduction of what is acid. Like for example, sometimes you have gastric or sometimes you vomit. Sometimes you have sick and you vomit. You will taste sour in your your things. Because why? Because you have your acid from your stomachs and you taste it with your tongue sensor. Right? So first one is properties of acid by smell or by feeling is sour. Okay. Right. So I mean, after chemistry 2, when you go eat or something, you're able to explain, oh, this fruit got acid or alkali. You're able to explain, right? And most of the time, like for example, the Coke, I mean the drinks with the can drinks. If you drink it, you taste sour, means they got acid inside. Okay lah, all this you know lah, all this so you know that taste sour. Tomato, all these things. So I should bring all this lah during the class, but a bit rushed today. But you know lah. Okay. So as what I introduced you just now, how you relate acids in chemistry 2, we relate H positive ion. Okay, acid are substance that produce H plus in the solution. You need to write this one. If the question asks you the give definition of acid, you need to give the full sentence. I highlight the yellow color means the keyword you need to write. right? So acid is a solution. Acid is a solution, it's not solid, it's not gas. It's a solution means it's a liquid form. Okay. The rest you read. Important part is you see H plus ion, that is acid in the solution. Okay. So why you taste sour? Because this H plus ion react with your tongue protein. Yeah, the protein of your tongue, because our tongue's made of protein, the cell, you react, then it gives you that sensation. Then send some electrical signal and then your brain will process it. Okay. Okay. So I think this one you did it before during your secondary school, right? You put in acid and then put in aluminum strip. We'll try to repeat this experiment also in our lab during your lab session. But I think you are able to imagine what is go. So and maybe you will see this one in your test too or final exam. Ask you to write the equation of some reaction, acid or alkali. Okay. Okay. So these are the properties of acid. First, you taste sour. You think of gummy bear. You think of some soft drinks, that lime, all these things. Okay. So these are some theory parts that might be asked you in the test or final exam, right? So it asks you the properties, mean how it tastes, how it looks, will it dissolve or not, and so on. You learn about physical properties and chemical property, right? So sour taste, dissolve any metals, not any metals. It dissolve many, not any. This is some careless mistakes. Some of you, you're right, many. Not many, not any, it's many. Many metals. So this one you think about aluminium. Then how you test it? You use litmus or pH paper. So litmus, you turn. Okay, litmus got two colors. Litmus got blue litmus and red litmus. So when you write your lab report later, you need to write carefully. Either you are using blue litmus or you're using red litmus. You use original, it is blue, change red means it become acid. If you use red litmus, original red color, change color, it means you are testing acid. Understand? So original, if you use blue paper change into red means you are having acid. If you are using red litmus, change into blue means it's something else. So it is also mean, but you need to understand what litmus paper you're using, like what I show you on the screen here. Okay, blue litmus change to red, right? So if you use red litmus, it will change into blue. So don't mix with the colors. Then another type of testing pH is universal pH paper. This one by professional. So when you mention in chemistry 2, don't just mention pH paper. I will put a question mark. What kind of pH paper you're referring to? Either blue, red, or universal. You need to tell me. Okay, if you use universal, you need to check the scale. You need to check the scale. This scale is given in the come with the universal pH paper. Yeah. Okay, important part. Again, recap. What is acid? Solution that generate H plus ion. You need to mention H plus ion. What is the property? Sour, dissolve many metals, turn litmus paper color. Okay, depend on what litmus paper you have. but it changed the color of litmus paper or pH paper. Okay. All this you read. Application of solid, HCl, sulfuric, nitric, acetic. This one you read. So I don't want to read in the class. You read what are the where we use it. For example, agriculture. Usually is nitrogen. They need nitrogen. Plant need nitrogen. Acid. Okay. In this chemistry too, usually I will ask you HCl, sulfuric, is made from fruit, nitric, acetic. Okay. Okay, how you know is, if you go into lab, how you know is acid? There's a label. If no label, then precaution, don't use it. Because you're not sure what you do. So you will see it's hydrochloric. You will see how many ml. You will see how many moles. You see CAS. CAS number means it's a international chemical ID number. For hydrochloric acid, for example, is 76 something. And some concentration, not on this page, another page. Okay. Hydrochloric acid, this one is your stomach acid. The one that if you vomit or you have gastric, or this thing. Okay. HCl, device structure, you should be able to do already. Again, careless mistake that we discover in test 1. Some of you miss out the valence electron. If you use the bonding, remember to put valence electron. H no more valence, because H maximum is 2 electron. That represent by the individual, the straight line. Okay. Sulfuric, many this one you read sulfuric means it's come from fruit. Okay. Acetic is vinegar. That is very common in kitchen. Vinegar, right? I like seafood, so vinegar is something that I like. Okay. This one you read. Citric acid is more on the orange color. But again, important again, what is acid is H plus ion solution. Okay. Okay, so this is just like sometimes exam question will ask you, give some example of acid. Give 3 example of acid. So you're able to write HCl, hydrochloric acid, citric acid, so on. At least you memorize 3 type of acid. 3 type of acid and 3 type of base, or 3 type of alcohol, alkaline. Okay, this one you this is base already. We already cover acid, already done acid. Now we go into base. Base means alkaline. So plant, how they defend themselves, they use alkali to defend themselves. Because if you use acid, acid will corrode or will destroy the protein cell and all this. So cannot. So plant will use another side, which is alkaline or base. Okay, these are the properties of base. Important. Acid and base property you have to memorize, or you at least you're able to tell these 3 points. How it tastes, what will it dissolve, and then how you test it. Okay, base or alkali will have bitter. Will something like salt, sabun. You'll feel sleepy. Something like this. So like most of the lotion, they are towards alkali. Your bath lotion and all this. a bit swiftly, right? And it will turn red litmus paper to blue. Means it will change paper. Huh? Okay. So and so on lah. This one you read. Okay. This is just for your info. This is in agriculture lah. I will ask. I won't ask you this one, but it's good for your info. For example, item that that tastes bitter, coffee bean. Some medicine also taste bitter if you accidentally bite some pills. Okay, soap is alkaline. Okay. Okay, so this one also you read through. Remember three types of alkali: sodium hydroxide, potassium hydroxide, sodium bicarbonate, or ammonia. The most common one, ammonia, right? Ammonia is very common in toilet, right? Bathroom. But they are very good for plants. They are good for fertilizer, and sometimes they'll use as an explosive uh, manufacturing. Okay. 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 So this is just a quick quiz. You are given three ingredients or three items here. Which one will likely to taste sour? HCl, or you look for those that have H positive. And H3? And H3 is what? KOH, of course not lah, because it's OH. Okay, so this one HCl lah, HCl. And H3 because you have three hydrogen. Yeah. Okay. HCl because it have individual H. Okay, next we go for molecular definition by using this. You'll be tested this one in your test too, and also final exam. Law called also cannot read this one. Arrhenius definition. Okay. Basically, what I start with the beginning of this chapter, I tell you about H plus and OH ion. Basically, this is Arrhenius definition. Means that if the question, if you see the question something like this, give the definition of acid and base based on Arrhenius definition. It means I'm looking for this answer, that what you see on the screen here. Means I'm looking for H positive and OH negative ion. Yeah. So if you understand this one, you should be able to follow through lah. Okay. So and then once you know definition, you ask to why question already. I give you one ingredient, answer why. Why it is acid, why is it base? By using the statement of this one. Okay. They must be in aqueous solution. Solid not count. They must be in a solution. Then only Arrhenius definition apply. Okay, this example lah, HCl. Because in HCl, it produce H plus ion. Okay, so this is how we ask you question. Give the definition of acid and base based on Arrhenius definition. You are given items below, item A, item B, item C, or element A, B, C. Define each of them either acid or base based on the definition given in your answer. So like this, something like this. Of course, HCl will not ask you anymore. Ask you other. Okay. So when in chapter 5, when you draw acid or base, you need to draw the ion in the solution. Basically, when you start answering, you need to draw a beaker or a container and then the ion inside. Okay. So this will be the equation, the first equation you see today. HCl aqua, you need to start with the state of that item. For example, HCl in test 1 or before 1, 2, chapter 1, 2, 3, I don't minus mark. But in chapter 5 onwards, or including final exam, you need to tell me the state of that item. Especially question from chapter 5. You need to tell me the state. For example, HCl bracket AQ means aqueous, become arrow, H plus aqueous plus Cl aqueous. It break into 2. So complete answer, if I ask you about HCl and define whether it's acid or base, this will be the full answer. You give me Arrhenius definition. Then from this definition, you give me why HCl is an acid, because it's produced H ion solution. You need to plus the stoichiometric or this equation, chemical equation. You need to write. After this, you need to write HCl bracket AQ arrow H plus bracket AQ plus C minus bracket AQ. This is the way of chapter 5 question and answer. Okay. Something like this. Right, what I write on the slide here. Okay. This is a complete answer for one question A, section A. Okay. So from there, basically you solve stoichiometric equation. And you need to tell me, start to rethink back chapter 1, 2, 3, whether it's a ionic compound, covalent compound, and so on. These two are ionic compound or covalent compound. Right? Metallic, you see metallic only, metal means metal. Okay. Okay. Covalent is non-metal plus non-metal. Ionic means metal plus non-metal. Metal plus metal become metal. Okay. We start to look into water. HCl is a covalent compound. What breaks into ion is because of water. Water make them into ionic ion. Water ionize it. Ionize it. So H plus ion are highly reactive. Highly reactive means they are actively grabbing something to join team with them, because they only have one electron. And this is H plus. H plus means they are lack of partners. So they have no partners. So they need to grab someone to join them, become stable. Yeah. Okay. So something like this. You start to see what you learned in chapter 4 or in your test 1 question. So how ionize react with water? H plus water Levi's molecule, H2O. H2O means you draw hydrogen, and then oxygen. Then you combine these two. H plus, when they combine, it will become H. What do you call? This is called what again? H3O plus ion, hydronium ion. So you combine what you learned in chapter 1, 2, 3, 4 in this chapter. H plus H2O become ion. This is question number 1 in test 1B. Okay. H plus means he have a lack of electron, so you combine. So you count how many electron? H plus, how many electron? How many electron valence? H plus. If it's H, 1 electron, right? H plus, no electron. If it's negative, 2 electron. Yeah. This is what you learned in previous chapter. So this one, no electron, plus here, how many electron? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 0 plus 8, you have to have total 8 electron on the output. Using the bracket because it's ion. Imbalance, it's not balanced. Okay? Okay. So this is just a remark and it's important to highlight in the red. Chemists often use H plus and H3O plus interchangeably. However, we will use H plus commonly because this hydronium ion, it can easily break away and become H plus because it's not stable. It's an ion, not stable. Yeah. Okay, a few more slides. Okay. So we start to do molecular formula, often write H plus first. Okay. So if you are having a formula with this HCOH2, formalic acid, let's say we take one acid which is called formalic acid. Formalic acid, the structure of formalic acid is HCHO2. The front H will be the hydrogen. The one that in the black color, CHO2, they are non-ionizable hydrogen. Okay. So if you do the arrangement of the equation and the bonding, like what you learned in your chapter 1, 2, 3, 4, it will become the one you see here. And you will see that actually hydrogen can pop outside the combination. H always go outside one. Like one question you see in your test 1. Okay, hydrogen can pop outside one. So molecular structure for formalic acid will be like this. H, although HC, this carbon, HC, although there is nothing there, actually there's a single bond there. So this is we call it shorthand chemical, shorthand Levi structure. Means we remove, sometimes it's too complex and we just remove all the single bond and we combine together, like suppose CH, OH. Yeah, so I think this is the first time you see this kind of simplified structure. In exam, please put in the single bond there. Okay. This one you read. Can you read? Okay. Another one. Just now we cover HCl. Acid, now we cover alkali. Alkali definition is solution that generate or produce OH ion in solution. So we take NaOH example again. You write NaOH bracket aqueous bracket. You will generate N plus and OH negative. If you see this equation, you see OH, it means you are generating alkali solution. If you see H plus, you are generating acid solution. Something like what you see on the screen here. Na positive and OH negative in the solution. Okay? And again, NaOH is ionic compound. Just now HCl is covalent compound. NaOH is ionic compound. Na is metal plus non-metal. OH is ionic. So ionic can break into ion. Okay. Just now covalent bonding HCl, why can it become ion? Because water energize, ionize it. Yeah. So if we combine acid plus base, we will neutralize. In chemistry, how you define neutralization? By this equation. Means that in chemistry, you need to tell the reader, you're actually taking acid H positive ion combined with the alkali or base OH negative. You neutralize it, you will see water. And remember the state, aqua plus aqua, and H2O is not aqua, it's liquid. This will be the careless mistake in test or final exam. Some of you, you'll write H2O as AQ. H2O is L, liquid form. It's not aqueous. Aqueous, normally we put for ion. Okay. So illustration, something like this. For example, you take acid HCl plus NaOH. So you know that HCl will break H positive plus Cl negative. NaOH, you need to write the separate equation, like what I showed you just now. Like for example, HCl, you write HCl arrow H positive plus Cl negative. NaOH, you need to write NaOH arrow Na positive OH negative. Then the next equation, if the question asks you neutralize, you need to write another new equation, which is take acid HCl plus NaOH or any acid or alkali that given in the question. Then you balance the equation. Na, usually, you see, HCl, H is the front, positive charge, negative charge, Cl. Object B, Na positive, OH negative. In neutralization, usually they will shift partner, they will exchange partner. Means Na, object number 2 base, will combine with Cl of acid. H will combine with OH base, become water. Okay, will become water. So in chapter 5 question, usually if you see neutralization already in the question, you need to write acid equation, you need to write alkali equation, you need to write neutralization equation, which is acid plus base become a compound, or in this case, salt plus water. So in this diagram, basically, sometimes the question will ask you, what will be the salt will be formed? It means ask you the product of neutralization. What will be the salt? Name the salt that be formed in the neutralization process. Means I'm looking for, in this case, NaCl. You need to write the salt is NaCl. You need to tell me that. That is 1 mark. Yeah. Yeah. So nothing complex here. It's just that you take H plus. What is H plus? Is acid. What is OH negative? Ion solution is alkali. Then acid plus alkali, you form water and salt. Okay, and salt. So this is the plus OH equation, you get form water. All right, but complete equation, if you neutralization, you need to write acid plus base, you get salt and water. Okay, we continue a bit. Just now is Arrhenius definition. Second, also important, what is called, I just call it BL lah. Bronsted-Lowry definition, or I just call it BL definition. You will see something like a pie here. BL definition, it helps Arrhenius definition. Arrhenius is only focused on two type of ion, H positive and OH negative. But there are ingredient or chemical outside there that cannot define using H and OH, although they are acid and alkali. Means that it do not, this BL definition, it help to define outside OH and H family that can be used for acid or alkali. But some element you see, in the equation, I cannot find H positive, I cannot find OH negative, but somehow it is acid, or somehow it's an alkali. We use BL definition. Let's say in the question, he asks you to use Arrhenius definition and use a BL definition. You need to give two lah. Two. Okay. So, okay. Arrhenius definition do not apply. Got limitation for Arrhenius definition. Do not apply to non-aqueous solvent. It means it only apply for aqueous solvent. AQ. Only AQ apply for Arrhenius. If it's not AQ, then how? If it's not AQ, you use BL definition. Means the state of that compound. Okay. We focus on transfer of H positive ion in the acid-base reaction. It focuses on the transfer of H plus. Okay. This one you read, This one you read. BL, because it focuses on the keyword is transfer. Transfer, when you transfer electron, there are two types of people we describe. If you donate, if you transfer, if you give up something, you are donors. You receive something from someone, you are acceptor. Yeah. BL a bit different. BL it look at how the H plus transferred. Means that if BL, you need to tell me who are the donor, who are the receptor. Who give H positive, who receive H positive in acid or in alkali. Alkali means OH lah. Who give out OH, who receive OH is the BL definition. BL focus on transfer of ion. This is, we start with acid first lah. If it's acid base, we focus on transfer of H plus ion. And there are two types of ideas, or we call it character in BL. If you donate some, if you give up electron or you give out the if you give out H positive, you are the donor. If you receive H positive, you are acceptor. So I'm looking for the donor and acceptor if the question asks you BL definition. You need to prove to me who is the donor, who is the acceptor. Can I? Arrhenius only look at H plus OH ion, and it's only apply for AQ solution. But BL, you look at how the transfer of ion, H plus for acid, OH for alkali. And you need to tell me who is the donor, who is the acceptor. Here we use it proton donors. Proton donors means is H plus. H plus in this case is not the nucleus inside one, not the nuclear inside one, not. It's just a name for positive charge, proton. It just named it as a positive charge. Okay, I give you an example. Okay. Acid based on Bl, acid, they are proton donor, mean they donate H positive. Yeah. They donate H positive ion or donor. Base, they are one who accept, receive H positive. They only look at who give, who receive. Mean the transfer of H positive. Okay. All right. Now, for example, HCl. The question can give you same element or same acid. It asks you to give two definitions. One based on Arrhenius definition, one based on Bl definition. Okay, for example, HCl. If HCl, if you use Bl, how? So you see, it donates proton to water. You write HCl aqua plus water. The water is liquid form, L. You'll get H3 positive aqua plus Cl negative. And just now, highlight in the red color, H3O plus equal to H positive. For chemists, H3O plus equal to H plus. Okay. Yeah. Okay. Same, same. Okay. So how Bl definition do? Water. Okay. I need to write the equation here. H plus react with water. How it react with water? You need to write equation. H plus aqua plus water liquid. You'll get hydronium with the H3O plus aqua. This one, you see this one already just now. How hydronium form. So HCl aqua plus water, it will form H3 plus Cl negative. So this one, HCl, remove H plus, and then the water will receive H plus. Water receive H plus, become H3O plus. Okay. So here, it associate, okay lah. So this one is the thing. Okay. This one you read. Okay. So if you take HCl plus water, you get H3O plus this one. So based on Bl definition, you need to tell me which one is acid, which one is base. Again, in this case, HCl plus water, HCl is acid, you know. But in this case, water become base. Water become alkali. Based on Bl definition. Although we know water is pH 7. But based on Bl, is focused on transfer of H plus ion. So HCl, he remove, he give out H plus. The one who give, it become donor. The donor is acid. Water receive, it become alkali. So you, in your answer, you need to tell me which one is the proton donor, which one is the proton acceptor. if the question asks you BL definition. Yeah. Okay. This one I go very fast because it's the same concept. If you understand what's BL definition, I give you another example. So for example, NH3. Just now the quiz question asks you which one is more likely to become taste sour, right? So NH3, if you use BL base, okay, NH3 plus water, and you see there's an interchangeable sign here, you'll get NH4 plus aqua and OH negative. This one, NH3 is a base. Water is become acid already. Just now, if you use HCl plus water, water is alkali, HCl is acid. But now if you use NH3 plus water, water become acid already. And NH3 become base. Because NH3 receive H positive well with base that do not contain OH, but okay. So means base means it receive H plus from water. Water donate ma. Yeah. NH3 become NH4 plus. NH4 plus means it receives H from somewhere. In this equation, it receives from water. When you receive H plus, you are acceptor, you are donor. You are acceptor means you are alkali. Then the water give water donate H plus, it become acid. So the thing is not permanent. Like for example, water, it's not permanently acid or base. You need to see how the reaction happens. Okay. Now, chapter 5 question, normally I will just give you the equation and then you tell me which one is acid, which one is base, based on two definitions. Arrhenius definition and BL definition. Okay. Let's read. Another word might be coming in final exam. Explain why that substance is amphoteric. For example, water. It can become acid in one case, it can become base in one case. So in final exam, I will give you the same example, not water. Give you some substance. Then in the explanation, last one, I ask you, explain why the substance is amphoteric. You tell me. Substance that can act as acid or base are amphoteric. In this case, what? Okay, in this case, water. But in the test, I'll give you one substance that can change acid and base. You need to tell me what is that substance that react as amphoteric. Yeah. Test 2 of final exam, you need to give me definition, then apply it. Yeah. Okay. The rest you read lah. You see double arrow means it's reversible. You're able to reverse, right? Okay. Okay. Just now we move from the left to right, right? If you see double arrow one, you need to be careful a bit. The question, if you see double arrow, I can ask you from the right hand side. Mean just now, if you from the left to right, NH plus is acid, OH become base. I can ask you NH3 plus water back to that one. So this one you read. This one you read. Conjugate acid-base pair is something like this lah. So what is conjugate acid base? Conjugate means they are partners, consists of two substances related to each other by transfer proton. For example, NH3 become NH4. This whole set means plus process some substance plus H plus, get the product. This is called conjugate pair. Same, this is another example. Water plus H plus become OH, become conjugate acid-base pair. Okay, on the left, it donate, it become acid. The result is alkali. This pair, this result is called conjugate. Same, huh? On the left-hand side, acid, it give, or this one is add. Add means receive. Receive become alkali. Okay, I think we stopped at 5.4 slide. Okay, we stop at these slides. Huh? We continue next lecture. Next week we continue. Eh? Oh, 2 o'clock already. Have class? Have no class.